Why is this a correctly balanced chemical equation, but this is not? Well, the short answer is that this down here wouldn't give us the smallest whole number coefficients. In other words, we can't have a fraction of a molecule. It would no longer be the reaction of interest because splitting an O2 molecule in half would completely change the chemical properties. And this is extremely important right here. What we understand as the correctly balanced chemical equation is what I've termed as the single unit of reaction, where we both follow the law of conservation and we have the smallest whole number coefficients possible. But one thing that is interesting is that while one works and one doesn't, they both follow the law of conservation, most obviously of atoms, as we have for one unit of reaction, 4 H's, 4 H's, 2 O's, 2 O's. But for a half a unit of reaction that we saw earlier, 2 H's, 2 H's, 1 O, 1 O. Therefore, we can say that following the law of conservation is necessary, but not sufficient. It's not enough for a chemical reaction to be correctly balanced. But how can we use this fact to correctly and strategically balance any chemical equation possible? Well, this analogy might be helpful. Being in San Diego requires being in California. It's a necessary condition. But just because we're in California doesn't guarantee that we're specifically in San Diego. We could be in San Diego if we're in California, but we could also be in San Francisco or Sacramento. So if we follow the law of conservation, it's like being in California. We need our equation to follow this law to be correctly balanced, but it's simply a prerequisite. It doesn't guarantee it. Similarly, we have all three equations meet this prerequisite of following the law of conservation, but only one of them is correctly balanced. Analogously, all three of these are in California, but only one of them is in San Diego, the California city of interest. Extending this analogy further, if we're not in California in the first place, say we're in Nevada, we can't possibly be in San Diego. An example of a Nevada equation is one where we don't have conservation in the first place. As with this particular combination of coefficients, 8, 5, and 10, we can't possibly have a correctly balanced chemical equation if we don't follow the law of conservation. But now we've crossed into California where we follow the law of conservation, but we're still not in San Diego yet. Right now we're in Sacramento where we don't have the smallest whole number coefficients. So to get to San Diego, we move within California. We reduce the coefficients down to their smallest whole number coefficients while retaining the law of conservation because 8, 4, and 8 are all divisible by 4. To really make sure you understand this, any balanced chemical equation must have smallest whole number ratios of just atoms, just molecules, or both atoms and molecules. I'll pause the video for a second so you can think about this. Well, we've just spent the entire video demonstrating there are coefficients which represent molecules must be in the smallest whole numbers possible. Thus, molecules must be in the correct answer choice. So let's cross out A, but what about atoms? When we have our balanced chemical equation for this particular reaction, we have a 4:2 ratio of hydrogen to oxygen atoms. And we can't reduce that to 2/1 because we would have to split O2 in half, which, as we already mentioned, can't happen. So we can say that just molecules, just coefficients, need to be in the smallest whole number ratios for our chemical equation to be properly balanced. Now, there are instances where atoms are also in these smallest whole number ratios, but that's super, super rare, and it doesn't apply to all chemical equations. In fact, it's so rare that the only example I could find is so unlikely to happen because when are we going to have a lone carbon floating around by itself? But in theory, if we do have this, our single unit of reaction does in fact have the smallest number atoms of 1 to 2, which can't be reduced further. And it also is the case that the only way that this could happen is if we have 1s for all of our coefficients.